types of variables in C++. Okay. So one way we know we can declare any variable with its required data type, and if required, we can initialize the variable there itself at the time of declaration. Fine. So this is normal variable. Okay. Variable. Whenever we say a variable, it is something like this, what we are referring to. Another thing, uh, we have a pointer. We have seen we have a pointer variable. So whenever we declare something like this, we say it's a not a normal variable, but it's a pointer variable. Why pointer variable we are saying? Because it can carry the address of a variable. Why it is a pointer? Because it carries the address. Why it is a variable? Because the address is not fixed. If I am saying I am putting address of A at this moment, further I can even say P is carrying address of B. So this is variable, right? In nature, P is variable. That is why it's called a pointer variable. Understood? Now it is not important that a pointer variable should be initialized at the time of declaration. No, I can do it in this way, that I have declared a pointer and then further I am initializing it with the address of some another same type of variable. That is important. A is also having the same type, that is int. P is also having the same type, that is int. Okay, so this is important. Same case with variables. I can simply declare variables and further, if required, whenever required, I can initialize the variable. So two steps are allowed. Everything is okay. So pointer is one entity which points at the address. Okay. So whenever we imagine a pointer, its value will always be a address. Like in a memory, if I create a variable a, its value will be always either int, always int, float, char, whatever built-in types we know. Pointer will always carry a address. Obviously, that address is also of some type. That address can be of integer type, can be of float type, can be of character type. So when I say p is equal to address of A. This is called as address of A. In this scenario, whenever ampersand is used with a variable name, it is called as address of A. Okay, remember this terminology. Okay. So when I say address of A, so whatever is the address of A, maybe 1000, that address, sorry, not here, that address is the value for P. Obviously, P will have its own address, maybe 1004, whatever it is. Understood. And due to this fact that P is carrying address of some variable, we say it is pointing to that variable. Getting the point? Now, if I have to print the value of A, I could have simply done it this way. Cout A. But when I have to print the value of A, by using the pointer I want to print it out, then I would say cout contents present at pointer P. How do we read this? I have told you. The star means contents present at. Contents at P. What is the value of P? 1000. Right? The value of P is 1000. So contents present at 1000. Whatever it is, suppose the value was 5. So 5 will get printed over here. Here also 5 got printed. Fine. If I try to, I mean, uh, yeah, if I try to print the address of P, you will observe the address value. If I try to print the address of A, you will see the address value for A, this 1000 and 1004 for that matter. Okay, see this now. We know int A is equal to 5. I'm keeping it like this. We know pointer which carries some address maybe of A, right? So another type of variable which we use is called as a reference variable. Now, until now, what I did, I directly mentioned the variable name. Thereafter, I mentioned a star. Now I am mentioning a ampersand. So let the reference variable be R. Okay, and equal to A, for example. Okay, so this sort of variables are called as reference variables. Now, what is this reference variable? The name itself says reference for A. That means in the memory, some variable got created whose value is 5A, whose memory location is something. And I'm creating an alternate name for that variable. I'm creating a reference for the variable A. That means it's just an alternate name for the variable A. So whatever object we created for the constructor, right? We created something like this. Now you can imagine what is the meaning of this reference. It is just a, a new name for the object A2, which we passed as argument for creation of A3 object. Understood? Now, what the reference variable carries, that means suppose if I go ahead and try to print maybe R directly, I say cout R, then what would I get in return? I will simply get 5. Reason is R is nothing but a alternate name for a variable. So definitely the same value I'll be able to access. If I say cout address of R. Now remember what I'm doing. I'm not using ampersand at the time of declaration, but apart from that, when I use ampersand with the help of along with R, at that time, what I'll get? I'll get the address of A because R is nothing but another name of A. So I'll get 1000, whatever the memory location is. Understood? Similar to what we did, use of star when declaring a pointer is to notify that it is a pointer and not a normal variable. That is why we are using star over here. But the use of star along with the pointer name when we use it apart from the declaration is something different. It says contents at P. Right? Similarly, this meaning of ampersand is different. It is just to notify if it is used, ampersand is used with a variable at the time of declaration, it means it's a reference variable that you are creating and not a normal variable like A. And whenever ampersand is used with the same reference variable's name again, then we are actually referring to the address of the referred variable, that is A variable. Understood? Is it clear? And that the advantage of this reference variables we took in case of copy constructors. So this is very, very important to understand. Is there any doubt? One important thing that if I declare a reference variable like this, like was the case with int a, I declared and then I initialized a. Similarly, int star p I declared, then I initialized p later with the address of a. So this was allowed, right? It is allowed, completely allowed. But if I declare a reference variable, something like this, int ampersand r, and later I try to, use that reference variable and try to try to initialize that reference variable basically later. So this is not allowed. Why? Because again, you can see the compiler will search for a variable r and normal variable r, and it will try to initialize that r with the current value of a, right? So this is not allowed. When we are using reference variable, we have to perform the declaration and initialization of the reference variable in the same step. That is important. This sort of initialization is not allowed. Fine. So a small point to remember in case of reference variables. Okay.